Greetings mere mortals, my name is Sean Shooping and welcome to my lab. In today's experiment I'm going to be bringing up a cluster of KVM pods using Metal as a Service 2.6 on these little things. So what exactly is a pod? A pod in the true sense of the word is a collection of resources. So over here we've got a pile of hardware, and inside each hardware component we've got resources like CPU, memory and storage. Together we have a collection of CPU, memory and storage. In Metal as a Service we've got two kinds of pods. We've got Intel rack scale design pods and we've got KVM pods. To put that into context, if this stuff was rack scale capable, we could consider all of this one pod. We could then go ahead and we could compose virtual machines from our overall collection of resources. A KVM pod, on the other hand, is simply a hypervisor managed through Metal as a Service. It's still considered a collection of resources, but in a much more confined sense. Consider this, you have a monster of a machine, something with 4 CPU sockets, half a terabyte of memory and 36 hard drives. To deploy a single operating system to that one machine will be a very cumbersome thing to deal with. Instead, you might want to carve that up into more manageable chunks and consume the resources on demand as and when you need them. In my case, I do not have a collection of monster machines. Instead, I have something a little bit more down to earth in the form of these. So the reason that I have this is that I wanted to bring the lab a little bit closer to home, and I wanted to get a little bit more hands-on with the physical bare metal, so to say. So with 5 of these things, I'm going to have 10 virtual CPUs to play with, 20 gigs of memory and like 2.5 terabytes of storage. So it's going to be an awesome little project. So what I do need is I need a Metal as a Service region controller, and what I don't want to do is that I don't want to use any of this hardware for the MAAS server. However, I do have this computer over here, but that is my desktop and I like the way that my desktop's currently configured. So I don't necessarily want to reinstall that. And I don't want to install Metal as a Service next to all my desktop apps and then have to deal with the cleanup after that. So instead, what I'm going to do is that on this desktop, I'm going to bring up an LXC container and I'm going to install Metal as a Service inside of that. So if you want to see me do all of that stuff, check out the card in this video. I'm going to link you to another video called MAAS in LXC with VLAN tagging. And as the name suggests, there's a whole lot of LXC wrangling with some reasonably interesting stuff that I've done on the network. Now, as you can see, it's been a while, but in the meantime, what I've done is that I've gone ahead and I've installed Metal as a Service on that computer over there. I've expanded the network and I've got ahead and cabled these nodes. So right now we're at the stage where we can go ahead and we can log into Metal as a Service and we can begin configuring the fabrics, the VLAN and the DHCP options. So I'll go ahead and fast track us through the boring bits, but essentially what I'm doing is I'm labeling the fabric, the VLANs, configuring some DHCP reservations, and then actually enabling DHCP to make sure that MAAS is issuing IP addresses into VLAN 999. So as it sits now, we've got our fabric named, we've got our VLAN declared, and we've got DHCP in a state of enabled. So that actually brings us to the point where we can actually begin enlisting these machines over here into Metal as a Service. So I'll go ahead and turn on these machines. They're going to perform a PXE boot and get an IP address from MAAS, and in a minute we should see 5 new machines appear in a state of commissioning, after which they should transition to a state of new. After that, I'll go ahead and I'll configure their power types. And seeing as these are desktops and not proper servers, I'll set the power type to manual and I'll just help MAAS along by manually turning them on when necessary. I'll then commission them so that they move to a ready state. And then at that stage, we'll be at a point where we can actually go ahead and deploy an operating system to them. Okay, cool. So now that the machines are sitting in the ready state, we can actually get to deploying our hardware. In MAAS 2.6, there's a wicked new feature that enables you to deploy a machine as a KVM hypervisor right from inside of the MAAS GUI. In previous versions of MAAS, deploying and preparing the node to a point where it was discoverable as a pod was completely up to you. Thankfully, that is now all completely automated in the deployment process. So if I go over here and I select all of these machines and I deploy them, all that I need to do is make sure that I select the option to register all of these machines into MAAS as KVM hosts. So after these machines have been deployed, we'll be able to manage both the bare metal as well as any virtual machines that we decide to bring up on top of them from a single user interface being MAAS. Now, isn't it a bit counterintuitive to have a product called Metal as a service managing VMs? Well, maybe, but at the beginning of the video, I was talking about large collections of resources and carving them up into more manageable chunks. If you're looking for a simple, no-frill solution to that problem, I think Metal as a Service with KVM pods solves that use case quite nicely. To bring up a virtual machine, what we can do is that we can switch over to the Pods tab. And here we can see that all of the deployed machines appear as pods. If we go into one of the pods, we can see how many resources it has and how much of that we've consumed. And as we can see, we haven't consumed anything. So I'll go ahead and I'll compose a virtual machine. And I'll just select all the defaults just so that the machine comes into existence. And after we click compose, we'll see the virtual machine appear at the bottom of the composed machine section. If we switch back to the Machines tab, we'll see our virtual machine appear exactly the same way as our physical machines appear in the machine listing. Things to note here is that the virtual machine now is completely controlled by MAAS. So I no longer need to help MAAS along when it comes to bringing the machine into existence or turning it on or anything like that. If we SSH into the hypervisor itself and run a virsh list --all, we can see that MAAS has gone and created the machine and turned it on. And if we really want to, we can actually watch the machine boot as if we were standing in front of it as it goes through the enlistment, the same way that a physical machine would. Okay, after it reaches the ready state, we can go ahead and deploy it. And after it's deployed, we can start using it and consuming it. To clean it all up, we can simply delete it from the MAAS interface. And if we switch back to the hypervisor shell, we can actually see that MAAS goes ahead and cleans up the machine quite nicely. Okay, so one of the other wicked cool features about using MAAS with KVM pods is that it works really, really nicely with Juju. So one of the reasons that I brought the lab a little bit closer to home is that I actually wanted to get a little bit more proficient and a little bit more hands-on with Kubernetes in my spare time. Now, in order to do that, my thinking was that I was going to use Juju to bring me up a small K8s cluster on this stuff. But before I can do that, I need to bootstrap a Juju controller inside of here. And what I want to show here is that managing MAAS becomes like a very hands-off experience, because MAAS will go ahead and bring machines into existence and install them under instructions of something external like the Juju CLI. Okay, so after the Juju controller becomes available, I can go log into that and create a new model for my K8s cluster as I was talking about. I'll make some modifications to the spec of the machines that I want, and I'll just simply go and deploy that. And then what the Juju controller will then do is that it will log into MAAS on my behalf, request some new virtual machines, and build the K8s cluster on top of that after MAAS has finished provisioning and installing the base OS on those. Okay, so as we can see, by consuming MAAS and KVM pods together and then strapping things on like Juju, we actually take our simple no-frills virtualization solution and we can actually turn that into something reasonably powerful. Now, in terms of MAAS with KVM pods, that's pretty much all that I have for you. If you've enjoyed this video, please consider subscribing to my channel. And if you've liked this video, give it a like, give me a comment, and as always, I will see you in the next video.